Hi everyone and welcome to this session about OVH Cloud AI training platform, and we're gonna see today how to use this platform for training your Hugging Face Wave 2 Vec scripts for the sprint of this week. So basically OVH Cloud is a European cloud provider, has 32 data centers around the world and is operating cloud at scale. And the product we're going to use today is used for scheduling AI jobs as well as having notebooks. It uses V100S NVIDIA GPUs that are 32 gigabytes VRAM. And you're going to have with this sprint with Hugging Face 500 euros vouchers, which is the equivalent of 10 days of training with a V100S. So the first thing we're going to do, we're going to go on the OVH Cloud website and click on the World section there. And you're going to click on Create, so My Customer Account, and Create Your Account. I'm just going to hold on while I'm creating the account. I just created the account. Now I'm going to receive a 2 validation step email. And I'm going to put this code in the web UI. I just put the validation code, and now it's going to set up all the information. You need to enter all the details for your account. I just click on create the account, and now the system is loading. You are now in the manager, the customer panel, and you're going to click on public cloud. Once you have clicked on the public cloud, you should land on the landing page of the OVH Cloud public cloud section. So we're going to create our first OVH Cloud public cloud project. And basically what we're going to have to put a project name. And I'm going to click, do you have a voucher? I'm going to click on this voucher page, voucher button. The purpose of this is to make sure that you are using the voucher that was provided by the Hugging Face teams or by us, and it should look like something like this, or full code that's going to be more explicit, like Hugging Face Wave 2 Vec sprint or something like that. Don't forget to click on the add button. This voucher should be worth 500 euros, which is the equivalent of 10 days of training on one single V100S. Remember that we limited right now the quota of GPU to 1 GPU per person to make sure everyone has a chance to get the V100S that has 32 gigabytes of VRAM, which is perfect for training on speech-to-text context. So don't forget to click on the add button, otherwise it doesn't work, it doesn't apply the coupon. Click on I have understood and accepted the following contracts, read the contract first, and I'm going to click continue. What's going to happen, and you're going to land on this page, just click create a project, or you can register your credit card for further usage. I'm going to create my project. By the way, guys, if you have any questions regarding this process, come on the Discord, the link is in the description, and come and chat with us if you need any help on anything. Okay. Now the project is being created. It might take some time. You can just click on the public cloud on the top left corner. At some point it should be starting to up. Here we go. If you refresh a few times, you're going to see your project popping up. So what you need to understand for the AI training platform, it is a bit special in the sense that it's made by and for data scientists. So let me give you an example, and I'm going to give you a general example, and then I'm going to be more specific about the Wave 2 Vec situation. So let's imagine you have some data, because maybe you are running the Wave 2 Vec on your own dataset. Okay, there are 2 ways to run the Wave 2 Vec training with Hugging Face. The first one is to use the Common Voice dataset, for instance. That is available on the internet, and that it's easier in this case to download it directly without within the job, without setting it up before an object storage and put the data inside it, etc. So what I would suggest personally is that if you're using the Common Voice dataset with the script I'm going to show you, don't link a data set bucket. It doesn't worth it. If you're bringing your own data, then you should also you should follow then the step of the bucket one. The second thing is that you're gonna store your models in the end in some place. Okay, if you're on Google Colab, basically it's gonna go in your drive. If you're on OVH Cloud, it's gonna go into an object storage, which is way easier to then share or then archive it. Okay, so we're gonna have one or two buckets. One bucket only if you're using Common Voice, two buckets if you're using your own data sets. Okay, let's focus on the first one, that is the data bucket. Let's say you want to use your data into the /workspace/data, and by the way, /workspace is usually the place where you're gonna have your job running with Jupyter, etc. Let's say you want to map this object storage or this data that is in a S3 bucket onto close to the GPU machine. What you're gonna do, you're gonna just say, I want this object storage bucket to be mapped to /workspace/data. Okay, and you can include even subdirectory. For instance, if I want to run on Egyptians, I'm gonna say Egyptian, for instance, is gonna find the subfolder within the bucket. Okay, and it's gonna be the same for the models, and I highly suggest, I'm really telling you to do it this way. You're gonna have your models like outputs, and if you are training, for instance, for Egyptian, let's say I'm gonna train a speech to text for Egyptians. Okay, it's gonna be in the bucket output models in a subdirectory that is Egyptian. And for the attachment, what we're gonna suggest is that the attachment would be on the subdirectory. Why? Is because if you have a training run, so each time you're doing a training, like you change the batch size, you change whatever, it's gonna synchronize everything if you put the whole bucket. So I'm gonna suggest that you sync only a subdirectory of the bucket that is related to the experiment you're running. So for instance, Egyptian batch size 16, you're gonna do that, or you can do something like that. Or if you change the learning rate, you can say batch 16 learning rate 1, 2, 3, 4, 5. Okay, and I would suggest that every time you do something, you just sync only the subdirectory of the experiment you're running. Why? It's because when you're running the job, the bucket will be attached to replicated and attached to the GPU like this for better performance. Like a GPU needs to have a full usage of VRAM, and for that needs to be fed very, very, very fast with the IOs. And network storage is not appropriate for that. I mean, network storage, especially like object storage situations, are not usually meant for that. So what we have built is something that is going to be kind of a gateway, object storage gateway, already for you, and is able to attach the data to the disk. So it's kind of synchronized down to the storage and then attached to the compute. And when you're done, it's gonna kind of sync up. Okay, so if you put all your experiments and you have synced all your experiments, like the system will sync almost everything. It's gonna check what is different already in there and is different. But if you have many files, it's gonna take like a lot of times to check what is different. Should I upload it or not? And then usually a training can be a bit big. So I would suggest that you have a strategy around the naming convention, like you would do on your laptop, but only synchronize what's needed. If you find it slow with synchronization post-job, it's probably because you didn't do that, and that's the biggest advice I have for you. Okay, now that being said, you understood that we're gonna have 1 or 2 object storage bucket to be set up. In OVH we call it object containers. So I'm gonna create an object container there, and I'm gonna call it output models. So there are 2 places where you have the GPUs, either BHS, which is the Canada one, or Gravelines, which is the French one, the West Coast French, European West Coast, so French, north of France. So I'm going to click on Beauharnois, for instance. I'm going to choose private there because you don't want the data to be exposed on the internet, and the name I'm going to choose is output model. Okay, output models. If you can have Beauharnois, it's good. Gravelin has more GPU, but Beauharnois is less used nowadays, so might be the right solution. You could have created, as I said, a container with your own data. Boom, I'm going to show you later. We don't need this for the first step of the, because I'm going to use command voice, but I'm going to show you how to upload your own data. It's very, very easy. The second thing I'm going to do, I'm going to go into the AI training platform. I'm going to accept the conditions, and you read it, of course. Remember that this is a testing phase service, so they might have some glitch there. There might be some few things that are not good. So come on Discord, chat with us. We're gonna fix it, etc. But this is a beta system right now, but still very reliable. But it's in the beta, and that's it. So once you are on the area of the AI training platform, you're gonna have to create a user. So what we did, we create an object storage bucket. Now we're gonna create a user that is dedicated to running those jobs, that have the permissions to run this job and access those jobs. So I'm gonna click on user management. I'm gonna create a user. I'm gonna call it Hugging Face, HF user. Next, I'm gonna choose AI training operator. I'm gonna confirm. I'm going to have a user and a password that is being displayed on the screen. So up, I'm going to store them. If you want to change it, it's very easy. So let me kind of have a copy paste there. Don't worry, I'm going to change it after the tutorial, but you can just click generate a password. It's going to generate a new one. So this is the new one coming. Etc. So the new password there, so I can change on and on. Okay, I'm gonna go back to the AI training section there. I have my user that is set. This is the username that we're gonna use, and the password is the one I've shown. So the thing I'm gonna do, there are many ways to launch it. You can use it through the user interface or through the command line. Okay, I'm gonna do it for the interface. Sorry. So I'm going to click on new job, launch a new job. There. Sorry. I'm going to click launch a new job. I'm going to choose Beauharnois. This is in Canada, and this is the place where I choose my object storage bucket. If you have chosen Gravelin, you can choose Gravelin. I suggest that your object storage bucket is close to the GPU you want to use. So I'm going to choose the same region. I'm going to click next. I'm going to add a custom images. As you see, there are many images that are already there, like MXNet, JupyterLab, FastAI. With JupyterLab, all of them have JupyterLab VS Code already implemented. But we have put MXNet, FastAI, PyTorch, Hugging Face, TensorFlow, and one of them is one image to hold them all. And in this one, it's kind of the Kaggle images, kind of the equivalence. It has TensorFlow, PyTorch, FastAI, MXNet, Transformers, and many others. This is my favorite one, but for the purpose of this week, we have created an image for you. When I say with Suraj Patil from Hugging Face and I that have put together the image, I'm going to give you the link down below. This is the one I've made, but it might have evolved, and maybe Suraj is gonna add new images with more features coming. So I'm going to click next. There, this is coming from basically Docker Hub. Okay. So if I go on Docker Hub in there and I put, here we go. This is the place where the repository for this is the place of the repository with the Hugging Face Wave2Vec image that we have prepared for you. You can prepare your own. It's very easy. It's based on Docker, so pretty straightforward. But by the way, we put everything on GitHub. So we can look into Wave2Vec sprint. I'm gonna give you the link down in the description, but you have the Docker file that is being used, and you have a few files that are gonna help you to go further. I'm gonna present it to you later. So I'm gonna click next. Now I put the containers. I'm gonna add the output models. See there. I'm gonna say output models there. What's gonna happen there is that if you do it this way, it's gonna synchronize the whole bucket, and I don't like it. So it's good to start with it, but it's gonna be slow at the end of the training if you do that for every training. So it's good for just a quick start, but I really don't like it for the long term. I'm gonna show you how to optimize the time of training afterwards. So you're gonna click on next. Yes, sorry. Okay, I'm gonna click on next. I'm gonna choose how many GPUs. As I said, we've limited the for now to one GPU, and that's why you're gonna have probably some errors that are gonna pop up if you want to run too many jobs at the same time. It's gonna say something like code 402 quota exceeded, please contact us, etc. So come on Discord to chat with us in those cases. I'm gonna click next, and you see that you have a CLI that is provided. I'm gonna show you after, but you could have run this with this command line, exactly this command line. So could have been done. You could have done it by yourself, just saying, with the CLI, and we're gonna use the CLI for the future. So I'm gonna click on create. I'm gonna check on the job. Should be fast to start to begin with, because you don't have any data to synchronize. Kind of the bucket is kind of empty. But if you start a second job and you already train something in this bucket and you synchronize the whole bucket, it's gonna take like a lot of time. So that's why I would suggest that after you're gonna use subdirectories, so you don't synchronize everything, but only your new training to download what's needed and re-upload what you have trained. And the point is, like, if you want to do fine-tuning, of course you're going to download the existing full bucket to do fine-tuning on existing models. But if you want to kind of run it from scratch or do a from scratch experiment, I would suggest that you address only a subdirectory. And I'm going to show you just after how to do it. So you see that the job is running. You have access to the HTTP kind of way to access the job, like with JupyterLab and VS Code, but you also have the resource details. So if I click on the resource details there, you're going to see that they are asking for a username and a password. That's the one we have set up previously. Okay, boom, boom, connect. And I'm going to have access to the Grafana, and the Grafana is going to give me the CPU, the GPU usage, the memory usage, etc., etc. So that's pretty cool to track your training. I'm going to click on the HTTP access, and you're going to see there are a few links there. We're going to add new links like blogs on how to fine-tune. This video will be also referenced on this later, but that's basically the landing page of your job. You can click on JupyterLab. Now you have the job running. With access to the JupyterLab, you can go into the Wave2Vec, which is basically the few scripts we have put it inside it, and you have your output models, which is the bucket, kind of. And let's dig into the Wave2Vec to have a very quick example on how to train with using Command Voice. So Command Voice is a dataset that has been built by Mozilla over a few years. They have built a speech-to-text that is a tool that is pretty efficient. It's called DeepSpeech, that is based on I think it's Baidu or implementation of speech-to-text, but it's pretty efficient. It's a bit different from Wave2Vec, but the good point is like they have built a library, but they have also built multilingual dataset. And that's pretty awesome. It's very qualitative. So with a lot of insight, like men and women talking. So it's more balanced than anything you're gonna find out there. So we're gonna have a first run on, for instance, Turkish, which is the one that has been chosen. So I'm gonna edit just the fine-tune.sh, and you're gonna see how it works. Basically, if you want to run a common voice training on Turkish, you're gonna use the Turkish TR, which is the Turkish ISO code for Turkish. You're gonna choose the output directory. So the output directory in my case is gonna be /workspace/output models. Okay, and I'm gonna choose to write into the wave2vec -large -xlsr -turkish-demo. So it's gonna, everything is gonna be synced up. The data directory, you can just put /workspace/data. As I said, this common voice is better to launch it, download it from internet, unzip it from internet. It's going to be faster than downloading a lot of objects that are not packed, kind of. And you have a lot of options that you can add, like the number of epoch, the batch size per device, train batch size, duplicate. You can say the learning rate, and there are many other things that you can add and iterate over. So what we're gonna do, we're gonna run this. So I'm just gonna save the few changes. You could have said French, for instance. French could have worked. Okay, so we're gonna say Turkish. I can click on terminal there, and in terminal you're gonna see I'm there. I'm gonna move to wave2vec. Sorry. And I can just fine-tune.sh. What's going to happen first is going to check if the language is appropriate. There are a limited number of languages available for common voice. So you're going to see it in the documentation. Anyway, if you put the wrong code, like you put, I don't know, TA, and TA is not supported by the dataset library that is being developed by Hugging Face, it's going to pop you an error saying it's not an appropriate code for the common voice dataset. So don't worry, there are a lot of error handling with this good library. So as you've seen, it has downloaded the data pretty quickly. It has unzipped it, and it's looking for cache. If you have cache, like if you do multiple training with the same instance. It's running, it has all the parameters, etc, etc, and now it's kind of training. Okay, so it's downloading the model, and there, the PyTorch model that you're gonna fine tune on, and now it's training. Okay, so boom, your training is running. It's gonna take a few minutes because it's very small fine tune. As you can see, it's only one step. Very few, batch size is not big, only one training, and I think the number of samples are very limited. So it's training. I'm gonna give it a bit of time to finish it, and okay, seems to be close to be done. It's running the evaluation, so you see the training is already done. Okay, and now it has the metrics, the loss, etc. So it has done already one iteration. So what we're gonna do, we're gonna look into the results. So I'm gonna look into output models. By the way, I could have just moved there and look into the output models. You see that the folder has been created, and you have all the results, including the models. You have the vocab. You have many other things. Okay. They might have some glitch. I experienced some glitch on multiple, a few languages, like 4 or 5 of them, because they were missing some vocabs in there. So you can adjust the vocabulary if it's failing, etc. So the output model is there. I'm just going to show you that it can be big. So this one is 1 gigabyte. It hasn't been trained for long. But it can be 1 gigabyte, can be more. So my point is, like, it's better to segment experiment per folder. So what we're gonna do now, we're gonna pretend that you want to shut down the machine, and it's gonna synchronize. Okay, and I'm gonna do it there. I'm just gonna go back there and click on stop. I'm gonna confirm. Okay, now it's interrupting. It's interrupting the job. What's gonna happen now? It's gonna synchronize the data back to the object storage. So it's gonna write into the object storage section. And remember, it was empty. It's still empty, and you're gonna see. I'm gonna refresh a few times, and you're gonna see the data is gonna start to come in and to be uploaded, re-uploaded to this object storage section. So in the meantime, it's gonna keep synchronizing. In the meantime, I'm gonna show you the CLI. So I'm gonna click there to get the CLI. You have Mac, Windows, Linux. I personally gonna use Linux. I prepared the machine there, and I'm gonna, oops, I don't see my screen. Is this machine running? No. Okay. I'm gonna go there. Sorry. Demo effect. Okay. So here we go. What I'm gonna do, I'm gonna download the sorry, I took a minimal image, so weird. Okay. I'm gonna install wget. Sorry guys for that. Okay, so I'm gonna download the CLI there. Here we go. It's there. I'm just gonna unzip it, of course. Okay, I'm gonna unzip it. Okay, I'm too lazy. Okay, and here I am with the OVH AI CLI. So I'm gonna move it to, so you should do the same. You can move to USR bin, for instance. It's gonna give you then access to the CLI. There are many ways to include it in your path. You can use also export path equal to existing path and adding the, for instance, slash wherever your file is. So my path to the CLI. Okay. So whatever, there are many ways to do it. I choose to move it to the binaries. You can always upgrade this CLI by clicking by just running OVH AI upgrade. It has many options. So let's look into these options. The first one is like you need to log in to connect this CLI to your account. So for the first thing. The second thing, you have a data section where you can upload your data to the object storage bucket in a very, very fast and efficient way. So if you need to put data, I would suggest to use this one, this tool. You have a dedicated registry in there. I would suggest that you don't use it, that you use the Docker Hub. Instead of this one, it's easier. You already have your login, your account is going to be saved. You can manage it from Docker Hub. It's very simple. So use the Docker Hub one. And finally, you can manage your job. Okay. So let's look at the OVH AI login. So it's pretty cool. They explain us how to create a user, etc. What I'm gonna do, I'm gonna log in through the terminal. I'm gonna use add user there. I'm gonna add the password that we have seen before is always the same. And now I'm logged in. Okay, so I'm gonna clear OVH AI. Who am I? I'm this user with this tenant and this trust ID. Okay, so I'm logged in, all good. What I'm gonna do, I'm gonna job list. I'm gonna list the jobs, and I see it's empty, but I can check whole. So it might happen that in the past you have run some jobs with your user, and you're gonna be able to retrieve it in the past. So this is how you see the jobs. You can run some jobs by using OVH run, and you see you have many options. So I just to have the options OVH run H. In there you can put your image. That's the first thing, and the second thing, you can use the set the number of GPU, choose the GPU model. For now we only have V100S. You can put a label, but you also can put a name, and that's pretty cool because we're gonna have, if you have many experiments, we need to name the experiments. We can set the output. I don't really need the output. You can attach volume, as I showed before, when I attach the output model bucket to the job. But I can add some subdirectories using the / prefix, and that's gonna allow me to only sync part of the data. You have some permissions like read and write, read only, and you can add a cache also to make it faster if you rerun your job, if you kill the job and restart it. And that's pretty much, there are a lot of other options, but I would just go into those ones. There are ways to connect to VS Code. I will let you check the documentation. The link will be below. But it's pretty efficient. And if you want to rerun a job from something and you don't want to type again the command, there is a way to resubmit a job using the from option. So you see there are many capabilities, and we're gonna just do a few of them. So what I can do first, I'm gonna go back to the job to see the status of the job we have killed. It's interrupted. It's probably syncing, and you see that the output models are there. It's pretty, you have a lot of data. I mean, it's kind of big, so what we call segment. When you have an object that is pretty big, it's gonna be splitted into sub elements, but don't worry. It's kind of not your problem. It's just a big object can be splitted into multiple elements. And you see that all the training elements have been brought up without anything to do on your side. And that's the beauty of these systems. This system. It means that if you run an experiment or multiple experiments, they're gonna sync automatically the result to the object storage. So you can sleep during the night and make it run without having to transfer the data and to push the data to S3 or whatever repository. Everything is in there, okay? And will be saved and can be brought up later. So remember what we have learned before. We have learned Turkish. Okay, and what we have run before was this command. Okay, I could have changed this command to have something that is more appropriate to the case I want. Okay, for now, the image I've shown you is pretty straightforward. Like you can do only one thing. So let me take back this into one single line. This is what we have run before with the UI. We have set up one GPU, we add the name, we attach the volume. Remember, it attached the full volume, which is kind of a bit too much for what we need. We only need one subdirectory. And we said this is the image I'm going to use. Now what I want to run my job, and I want to run multiple jobs. Like my dream is to say for language in, and then I'm gonna say French, Turkish, Chinese, Greek, etc. Do train me, kind of train the job. So it's gonna be OVH AI job run, and you're gonna say blah 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 my language. You're gonna say done. Is gonna send a lot of jobs, okay, and each of the jobs will be stacked in a queue, And when the GPU is available, or once the training is done on your side, the GPU is gonna pile up this new unpile this new item, and it's gonna bring it and train it. So you don't have to do anything; it's already orchestrated. So that's the dream. Let's build this dream. So now let's assume I want to train a French model. So what I'm gonna do, I'm gonna just reuse the same the same command line that we had before, except that I'm gonna change the name of the job. I'm gonna say the model will be FR. Oops, sorry about that. I don't know. Okay. So I'm just gonna change the name of the job, wave to vec dash fr to say French. I'm gonna attach the volume, but look at that, it's a bit different from the previous one. The previous one I just said give me all the bucket. For this one I'm gonna say you just sync the subdirectory /fr, so the bucket is output model /fr, but fr does not exist, so the system is going to create a subdirectory in the bucket and only sync this subdirectory to the path I've chosen. Okay, and that's going to make a big difference. So if you train multiple times, multiple jobs, etc., you should segment every job with a subdirectory. I suggest that, otherwise it's going to sync the whole bucket and it's going to take like a lot of time. So what we are seeing now, it's I'm gonna sync the bucket that is output models that is located in Beauharnois BHS data center. I'm gonna sync only the /fr subdirectory into the /workspace model /fr in a read and write mode, and I'm gonna use the data buzzword /hf wave to vec. Okay, so I'm gonna run that. What's gonna happen? The system is saying, oh, okay, it's running. By the way, you can get the status of the job. You can say OVH AI job get, and you put the ID. It's gonna give you the status of the job. If you are syncing data, you're gonna have the sync progress. So if you like having data that you are syncing the bucket back to the GPU, you're gonna see the progress of the sync. But it's gonna give you basically it's gonna give you job. Is the status of the job. Okay, I can check the status with OVH AI job list, and you see this job that I've just run is running with this URL. So either you click it or you copy paste it. I'm gonna go in there, and what I'm gonna do, I'm gonna just go there, and you see you can have the Jupyter Lab, Visual Studio, and so the same environment as before. If I click on the Jupyter Lab, what you're gonna see is output models, and you see I don't see the Turkish. Okay, so I didn't sync back Turkish, which is good because I don't want to resync every job I'm running and every output I'm running. So it's a good thing, and I still have the wave to vec. So it's French, it's not Turkish. So as you've seen in the example there, it was Turkish. How do you make it French? So let's start a command line to show you how the Docker is built, and you're gonna see environment variables that are being set there. There are many environment variables. Should be even more of them. Anyway, yep, see, you have output there, for instance, there, that is already set up for French. That's an example. You have a model name. So there are some predefined statements like the per device, the number of train epoch, etc. So you have many things that are already set up. Okay. So those environment variables, I put it in there. I mean, in the Docker file for you guys, but you can override it. Okay, so it's pretty efficient. So for this one, I'm gonna keep French, etc. But let's say I want to train, instead of French, I want to train another language. The only thing I need to do is either doing export and change there to another language, like I don't know, Italian. I'm gonna export another one, which is the dataset config name, for instance. I'm gonna say export Italian. Now the language is being set to Italian. I can change also the models, by the way, like change the Facebook model. But as you can see, I have no parameters. And I'm going to use this script, which is fine-tuned with params. That's going to take the environment variables and apply them. So it's not predefined, it's reading dynamically from the environment. So let's fine-tune. Sorry, I need to change the path. Perfect. So I'm going to say fine-tune with params. And now it should be running with Italian. And as you can see, it's going to Italian. Okay, so I'm not going to run it because I was supposed to do French, but whatever. The default was French. Sorry, I'm French. That's giving you an example of how it works. You have the fine-tune with params script that's going to have all the environment variable. And this is where the beauty of the system is. Let's go back there. I'm going to kill this job. Okay, I'm going to say, sorry, OVH AI job. Stop this job. Okay, so it's going to be OVH AI job list. It's interrupting, so it's being killed. Okay, perfect. Okay, so what I'm gonna do now, I'm gonna run for Italian, French, and English. I think we have Italian, French, and English, and maybe a few other languages. If I go back on the GitHub, sorry, so this is not this one, sorry. Up. I think it's Wave to Vec Sprint. I already gave you the Wave to Vec languages, so I have many languages, so I can take the Basque one, for instance, this one. So I can take Spanish, for instance, Spanish, Italian, and French. Let's say I want to train Spanish, Italian, and French. Okay? So my languages, I'm gonna say 4 languages, so L. In, I'm gonna say Spanish, French, and Italian. I'm gonna do OVH AI run. Okay, job run. What I'm gonna say I want to have 1 GPU. I want to have HF Wave. That's the name of the job I want. Wave to Vec. And I'm gonna say give me the language. So L. Append the language. I'm just gonna echo it just for you guys to see it, and I'm gonna run them. Okay. The second thing I'm gonna say, I'm gonna attach a volume. Sorry, and I'm gonna say the output model will be okay / the language. Okay, so it's gonna create a subdirectory in the bucket for each language to avoid syncing everything. I'm gonna say \L in the read and write mode, and usually we should have said data buzzword, etc. The problem I have there, the big problem I'm gonna have, is that I didn't set the language in the script, okay, for the training. So what I'm gonna do, remember the script with params. Sorry, the script with params it has some environment variables, so I can override them. So the output here, for instance, okay. So what I'm gonna say the output here will be equal to /workspace / output models / this thing, okay. Another environment, so that's gonna override the output here. The other thing I'm gonna have is the dataset config name. This is where I put the language. So I'm gonna say dataset language name equal to language, and that's basically it. If I want to change number of epoch, etc., I can do -e and override the default. So then I'm gonna say done, and it's gonna say okay. See, language Spanish, French, Italian, Spanish, French, Italian, and the language will be different. So if I run this command, all the jobs gonna go in the queue, and once the job is run, it's gonna take the next one and run it. So you can run experiment like this way. So it's super nice. Okay, so now not echoing it, but I'm gonna do that. So it might not work, and the reason why is because it's a beta product and we put quota on it. So if you face any problem with like I'm facing quota limitation, please contact me on the Discord. I'm gonna either raise the quota or we're gonna work together around this topic. We did that to make sure that all the 200 participants got a chance to get a GPU right now. So I'm just gonna run and see I'm gonna have quota exceeded. It's because we have limited to 1 GPU per user right now, per account, to make sure everyone's gonna have a GPU to run. But in some cases we might increase the quota. Just come talk to us on the Discord, and we're gonna discuss that. If you run on 1 GPU, you can have, with 500 euros, you can have 10 days of training. If you run on 2 GPUs, if you take minus GPU 2, it's gonna be 5 days of training. If it's 4 GPU, it's gonna be like 2 days of training. So make sure that you select the appropriate number of GPU if you are eligible to multiple GPUs. So to sum up, what we've seen and what's important, okay? Let me put that back. Key things. The key thing is like, don't forget the prefix. It's super important. Otherwise, after the job, the sync will be taking forever, okay? And you can't run a new job because of the quota limitation we have done in the sprint to make sure everyone has a GPU. Because of that, if the sync is taking forever, you're gonna have to wait forever for the job to finish to rerun a new job. So I would suggest to go through subdirectory. Maybe it's the most important thing I'm gonna say in the video. The second thing, you have seen that there are many ways to run multiple experiments like this, and you can get the status. It's very easy. So sorry, my bad. I forgot to mention one thing. This is gonna run only this UI. It's not gonna train it, okay? This is for the UI. If you want to train, and sorry about missing that. Job stop. Oh, up. I'm giving the ID. Okay. So if you want to run this job, but you want to train with the params you have set, because now I just put the usual command that you have built in. You need to set up and say, I want to run the param, okay? So, oh yeah, I can't run it, it's being killed. I just need to say, go and run this script, okay? Because otherwise it's just gonna run the Jupyter Notebook. We don't want something to run out of the box. So we're gonna just put a command there, minus, and we're gonna say fine tune with params. And this script is sh/ it's located in the workspace /wave2vec / fine tune with params. So basically when the job's gonna start, it's gonna look into this instead of looking at the usual boot script, which is to launch the Visual Studio, the JupyterLab, etc. So if I do that, now it's gonna run by itself, and maybe not running the notebooks. If we want to run the notebook, you can say, and I think it's something like run all, something like that. Run all. And run all that is sh. I think it should work this way. Run all will run the notebooks and the rest, but I'm not sure about the run all, so whatever. We're gonna take this one for the Spanish. I'm just gonna run it. What's gonna happen now? It's in the queue of VHAI job list. The job is initializing. So VHAI job get. I'm seeing the status. There is no sync that needs to be done. Even if the volume is being attached, as we can see there is a volume attached. and we see the environment variables. So we're gonna say, okay, job list, it's there. It says it has an URL, but you're gonna see that in fact it's not working because, very simple, I didn't start all the servers like the Jupyter Labs, etc. But it's actually running. So if I go there, OVH AI, and the training is running, and I say job, I say exec, I put the ID of the exec, I say bin bash, for instance. So I'm gonna get into this running execution and go into the bin bash. I can access there, I can see HTOP, I can see NVIDIA SMI, NVIDIA SMI, I can see the GPU is there. So now you can see that the system is running. Like we see the Python run command voice, we see the command that is running. So if I put 3 there, we're gonna see that, of course, the command has been set up running with all the environment variable that we have set all together. So you don't need to have a Jupyter Notebook to make it run. It's pretty straightforward. But let's say you want to have the Jupyter Notebook running. I think you can do something like run all.sh, and boom, it's gonna start the notebooks. So I can access the URL, as you can see there. It's gonna give me the URL. So here we go. So basically what I've done there, I've started the run with params. So I took the environment variable and I built a training out of that using an environment variable that I've been overwriting with the execution. But I can see also I can run by myself also the Jupyter Lab. So if I do NVIDIA SMI, I can see HTOP. I can see that the process is running. Probably it's downloading the data right now. So we're gonna see there. Oh, data is there. Yep, it's downloading the data. And it starts to have multiple processes running. So we can say something like this. We can add a terminal. We can put them side by side. And I can say NVIDIA SMI. I'm gonna say up, watch, for instance. So we're gonna wait a bit, but you see that the data is coming, and they're gonna start to have the training that's gonna run soon. So the cool thing is that I can also check live my training. So for instance, I can say, so I'm gonna resubmit this job. I'm gonna say OVH job run from. I'm gonna rerun this job, and what I'm gonna do is OVH AI job list. You can see it's initializing, and I'm gonna say OVH AI job logs, and I can say -F to follow the logs, so meaning it's gonna run live. So now it's not ready yet, but once the job will be ready, it's pending to be scheduled, but once it will be ready, we will be able to see it. So gonna wait a few seconds. Okay, now it's running. So let's try to look the logs, and boom, OVH AI job logs -F is gonna follow the logs of the job, and you're gonna see the training running by itself within the terminal. So it's kind of following the logs of the command line we have set up. So I hope it was clear. I wish you a very good sprint. Don't hesitate to come to the Discord to ask us some questions directly. There is a channel that has been set up for you directly, which is the HF Wave2Vex Sprint channel. So all the links are in the descriptions, and enjoy the week. Have a good day. See you.